So one of the next things that is important to consider is how to create a new comparison. So the way that's done, looking at the navigation across the top here, I have my experiment summary, a listing of all of the samples and the sample information, a set of downloads with an important set of information, including a full export of all of the comparison data, by the way, as a download, in case there's a desire to do data mining offline. The discovery and analysis, which is where all the comparisons live. This is the filters for this particular comparison we're on now, and we're currently on this differential expression view at this time. So what we're going to do is we're going to go ahead and click on Discovery and Analysis. And by doing so, I see all of the comparisons that exist inside of this experiment. So all normalized expression abstracted from any comparison. So if you're looking for a gene and you're not seeing it in a comparison, that's where you want to go. If you have a knockout experiment, you want to confirm that the gene is knocked out, you want to look for that information, you can find it here. Also, as a request from several of our pharma customers, we enabled GSVA analysis, and it provides a view that is term-based, not gene-based. So it's a really interesting way to explore experiments, especially when you're working with clinical trial data and you may have a high degree of variability across subjects. Term-based exploration is a really great way to look at the main variables that are driving across a potentially diverse data set. Here we can see a series of comparisons. This is one I was just working with, ARS 1620, and this was with a covariate correction across cell line. I can see there is a covariate meta-analysis that's available here. This is the baseline comparison for the same one. This is the uncorrected one that is paired with that one. And then we have two other comparisons that are here. So we have one for the cell line LU65 with trametinib, and we have one that was looking at the time course. So let's say I want to go ahead and add a new comparison. So I'm going to go ahead and click Add a Comparison. Once I do, Rosalind immediately launches into the comparison builder. Now, one of the old school ways of building comparisons was you had to remember on your sample sheet all the different aspects of the experiment. Here we have 32 samples, 5 different treatments, 3 cell lines. So it would be very challenging to come through here and try to make sure I'm grabbing the right samples to build a comparison using the samples. Really do not recommend trying to do that. And I understand that this is the way that many biologists and researchers have had to do things in other systems. We're really happy to say just add the metadata. It's going to be incredibly useful. We follow the NCBI biosample bioproject data model. It's going to pay off. So set up your experiment, put the right metadata in. You can use it when setting up experiments. And when it comes time for publishing, everything is already in the right data model ready to go for import. So here we're going to go ahead and get started with treatment. So let's say that I want to take a look at, let's do ARS 1620 versus DMSO. And notice as soon as I did that, that just filtered down. So initially there were 0 eligible samples. As soon as I drop that in, I can see I have 12. Now I might say, well, all right, let's get specific. Let's do this for H358. So as soon as I drop in H358, Rosalind says, oh, well, you have 7 that meet the criteria of H358 with this treatment. And I have 8 down here with DMSO, but I need to drop that down there as well. So we've got 3 with the control on that cell line. So we've got a good apples to apples. And, I probably want to pay attention to time course. So let's make sure that we do 24-hour. And sure enough, now we're down to 24-hour. Couple more points to emphasize. Control is always on the bottom. It's incredibly important to mention. That does affect directionality when looking at your results. The results will be the same, but what's up, what's down will vary. So make sure control is always on the bottom, treatment is always on the top. And you'll notice as I did this, Rosalind intelligently named everything for me. The name of the group, which I can modify, as well as the name of the comparison, which I can modify. What's interesting is the intelligence in the platform. Notice that there's no reason to duplicate the cell line name across the 2 sides because it's shared. And there was no reason to duplicate 24-hour onto one side, condition versus control, because that information was shared. So that's going to be automatically named for you. So you have the shared variables or attributes, and then what you're really comparing. I'm comparing ARS-1620 treated with 1 micromolar versus DMSO. And frankly, I can just take off treated because that's a redundant word and just say it's ARS-1620 versus DMSO. That's exactly what I want. I'm ready, and I can scroll below and I can click save and run. Now, by the way, if I had chosen a set of variables or attributes that does allow covariate correction, this would have lit up, and I'm going to demonstrate that here in a second. So I'll go ahead and click save and run, and you can create an unlimited number of comparisons in your experiments. Rosalind does not limit you from that, so as long as you have active subscriptions to the platform, you are enabled to be able to get that done. So right now, just going back in to create another comparison. And notice, of course, I didn't have to stick around and wait. That got deployed to the massive Rosalind cloud system. It's processing that for me. I can just keep going. I don't have to wait. And so I'm going to set up another one, and I want to show how this covariate works. So let's go back to our treatment. So we have ARS-1620 versus our DMSO, and I drop that down. Notice immediately covariate lit up. So I can click on that, and Rosalind will tell me I have one valid variable that has both samples on both sides. I can go ahead and click that I want to do a cell line correction. And once I do that, Rosalind will put the covariate correction tag here on the end for cell line. And that will now analyze across 3 different cell lines and find the information on what the difference is in differential expression when I adjust for that confounding variable of cell line. And other cases that could be done by age or gender. So using covariate correction is a great way to gain greater insight into your experiments.